Hello, Julian here from PopcornFX. In this video I'll show you how to compute the distance traveled by a particle using discretization. So this builds upon the previous video which showed the basics of discretization, so I encourage you to watch it if you haven't already, because I won't go back to some of the concepts I talked about in that video. So here I have a simple test rig with particles that flow upwards, follow a turbulence, and leave a trail so their path is more easily visible. So the trail particles are just rendered with a simple ribbon and fade over time using a curve. So I want to take the position of the particle each frame and to accumulate the distance traveled since the last frame into a counter to get the final total traveled distance since the particle was born. So in order to do that, the first thing I need is, well, how much distance the particle has traveled since the previous frame. If the particles were traveling in a straight line, I could just use the start position and the current position, subtract the two, get the length of that. But here, because the path is non-trivial, they follow a turbulence, I can't do that. So they still travel in a straight line, but every frame, and between frames, obviously the path isn't a straight line. So I can take this small move vector each frame, get the length of that and accumulate it, and it will approximate the correct traveled distance. So to do that, I'll take the position and I will subtract from it the previous position of the previous frame. So to get the previous position, it's actually very easy. You have a node that does that, which is previous frame value. So I wire position into the previous frame value node, and it will give me the value of the position at the previous frame. So I just subtract the two, and now here I should have my move vector. So when I get the length of that, I have the travel distance. So I will again use my debug draw screen number node. I will wire in the travel distance. So this is the travel distance in a single frame. So let me quickly make this a bit more readable. Perfect. And a small up offset. Yeah, that looks nice. Okay, so here you'll see that if I change the frame rate, if I go to 7 FPS, well, the number displayed is much higher than when I'm at uncapped frame rates and very slow update rates. So yeah, this is indeed the travel distance. So I want to accumulate that. So I'll start with a travel distance of 0. I will drop a discretization point, and I will simply, every frame, add the travel distance, and then I grab that result, and there I have the total travel distance. So pretty straightforward. And of course I can make a node out of that. So I just select all the nodes, hit Ctrl G, and here I have my travel distance node that I can then easily reuse inside different effects. If I check the public checkbox here on the template, I will be able to use that node in different effects. And I can even do a debug helper there, display traveled distance, and this will be my debug node. That's all for this video. Hope it was useful, and see you next time.